My name is Alessio Alario. Today we will look at the installation of two Any-Grid PSW-H units, but this video also applies to the Any-Grid PSW-B series. We will show you best practices along the way. Please hit the like button and subscribe to our channel for more content such as this. The installation of any power equipment involving voltages above 60 volts should only ever be attempted by an electrician. Please refer to the manual for various safety guidelines. Ensure that you're always using tools adequate for the job, and in this case, insulated tools. The first step in the installation involves finding a suitable location for the installation of the inverters. They should be placed in a dry and cool location, and they shouldn't receive any direct sunlight. Ensure that they're mounted in such a way as to satisfy the requirements for both sideways and up and down clearance to any walls or other equipment. This is to ensure a good airflow and to make sure that the devices stay cool throughout operation, prolonging their life expectancy and making sure that the devices don't go into derating unnecessarily because of overheating. Ensure that the room you have selected for mounting your Any-Grids is relatively dust-free to avoid the filters clogging up and again to prolong the life of the Any-Grid product. Also, please note the Any-Grid series has forced cooling. This means there are fans on the inside to cool the devices down. This naturally causes noise, so it is not recommended to mount the Any-Grid anywhere near a bedroom or in living room quarters. For safety, also make sure that the Any-Grid is locked in a room so that children and other unauthorized people do not have access. It is most important for the inverters to be as close as possible to the battery. This should be your first priority. In the case of the PSW-H, a battery is not strictly required, so maybe this is not a condition for you. Next, it is important to be close to the AC electrical distribution. This is where your AC loads are connected. If you're using an AC source, this is typically also where your AC source comes in. PV is less critical. You can be dozens of meters or even 100 meters away from the PV array, so this is your lowest priority. PV wires can be quite long, but due to the high voltages involved, the losses are negligible in many cases. This is a good time to remove the bottom cover of the Any-Grid device you're using. This will give you access to all the connectors required to connect battery, AC input, AC output, and PV. Once you've found a suitable location for the Any-Grids, it's time to hang them on a fireproof wall. The Any-Grids are designed to be mounted vertically for best airflow. For the following wiring steps, it's important not to connect to the Any-Grid until the very end. This is to ensure that the Any-Grid is not powered up unintentionally and that there's no arcing or sparks that evolve when you connect to the Any-Grid. For this reason, amongst others, it is important to have breakers between the Any-Grid and the battery, between the PV array and the Any-Grid, between any AC sources and the Any-Grid, and between any AC loads and the Any-Grid. Next to the prevention of arcing, it's also important to be able to switch off any of your power sources, be they DC, such as PV or battery, or AC, such as a potential AC source, so that any potential source of energy can be disconnected safely from the inverter for any servicing. As mentioned at the start of this video, it's paramount to use insulated tools. Any connection to the grounded housing of the Any-Grid from any of the PV terminals, for example, or the AC output phase will cause damage to the Any-Grid. Also, using uninsulated tools on high energy devices such as batteries can cause very destructive short circuits and cause overheating or even fire in a worst case scenario. It also increases the chance of electrocution when working with high voltage sources. For general best practices regarding wiring, please see the link down below. Next, turn to the battery wiring. Prepare a suitable cross-section of wire at the necessary length. As mentioned before, it's important to keep the battery wiring as short as possible. We recommend no more than about 2 to 5 meters if possible. The further the distance between the battery and the Any-Grid, the more important it is to stay towards the upper end of the battery cable cross-section recommended in the Any-Grid manual. Once you have a positive and negative wire prepared at the correct length, remove insulation on either end according to the manual. Then crimp on the ring terminal that's included within the Any-Grid package. Make sure that you use a suitable high-quality crimping tool, preferably in the positive wire. Cut it in two and insert the breaker as close as possible to the battery. This is not only to be able to disconnect the battery at will to service the inverter, but also to be able to protect from any short circuit that might happen between the wires. Once the breaker is installed in the positive battery wire, make sure that it is in the open or disconnected position so that the positive wire is interrupted. Then place the ring terminals from the battery wires that you've prepared onto the corresponding polarity battery terminals of the inverter. Now reapply the nuts and tighten them with the torque as specified in the manual. Continue by connecting the other side of the positive and negative wire to the battery terminals according to your battery manufacturer's requirements. Now that the battery is wired, let's take care of the AC input and output connections. The AC input connection is optional on all PSW-H and PSW-B devices, so if you're working in an off-grid scenario, this may not be required. It is important for all Any-Grid PSW-B and PSW-H devices to be properly grounded, so it is mandatory to connect the PE, in other words protective earth, terminals of the inverter to a suitable ground. A suitable ground is defined differently in various countries, but typically it means a low resistance or low impedance connection to ground with a suitably wired cable cross-section. Prepare all of the necessary AC input and AC output wiring depending on whether you're using a single-phase, split-phase, or three-phase system. If you're using an AC source, between the AC source and the AC input of the Any-Grid, make sure that you've installed a breaker. Between the AC output of the inverter and your AC loads, it is important to have not only a breaker, but also an RCD or a residual current device. This is mandatory in many countries, as it is very important for safety of the people using the electrical equipment in the home or the location of the installation. An RCD works by comparing the neutral and phase currents to each other. If the difference between the two exceeds the value that is considered dangerous to humans, the RCD will simply trip and disconnect both neutral and phase between the source, in this case the inverter, and the AC loads, therefore protecting people from injury. In order for an RCD to work, its neutral must be referenced to ground. In other words, somewhere in the electrical system there must be a bridge that connects the neutral to the ground of the system. In grid mode, the inverter is connected to both neutral and phase of an AC source. It is usually mandatory for a neutral to ground bridge to be made near the AC input of the inverter in the existing electrical system. However, when the inverter switches to off-grid mode, it disconnects both neutral and phase from the AC source. This also removes the reference, or in other words, the bridge that's between the neutral and ground. For this reason, all of our Any-Grid PSW-H and PSW-B products automatically make a new connection between neutral and ground to ensure that an RCD is always working and to provide optimum safety. Now back to the wiring. Prepare the wiring for the phases and length required and remove insulation on either end. Make sure that all phase lines are interrupted by a breaker, and make sure that that breaker is in the open or disconnect position. Check the Any-Grid manual for details on how to size the breaker. Ensure that the inverter is grounded as a first step when wiring. To do this, connect the PE terminal of the AC output to ground, and if available, also the AC input to ground. Once the inverter is grounded, continue by connecting the neutral and phase wires between the AC input of the inverter to your AC source, and the same for your AC output to your loads. Typically, both the AC source and the AC loads come together in an AC distribution box, which houses all of the necessary breakers, the RCD mentioned before, and any other protective equipment that is required in your home. This is also the place to put the SPD, or the surge protective device, to protect from any surges coming in from your AC source, so for example from your grid. At the end of the section, your AC input should be connected to the AC source via a breaker and an SPD, and your AC output from the inverter should be connected to your AC distribution box via another breaker and an RCD. With the battery and AC in and output wired up, it's time to look at the PV connection. Make sure your PV array is wired in such a way so as to never exceed the maximum voltage allowed by the Any-Grid PV input. Absolutely take into account that the colder temperatures get at the area of installation, the higher PV voltages get for crystalline PV modules. This is typically explained with a temperature coefficient in your PV module datasheet. It tells you by how much the voltage rises as temperatures come down. Also make sure that your PV array exceeds the minimum voltage requirements as explained in the datasheet and the Any-Grid manual for the PV input. As a last step, make sure that the MPP current of your PV array does not exceed the Any-Grid capabilities. If you're working with a PSW-B inverter, chances are you will have more than 2 strings. In this case, you will require a combiner box to merge all the positives and negatives together so that you end up with a single positive and negative to route to your Any-Grid PV input. The PSWH inverters allow much higher PV voltages. This in turn means that the current is kept lower and that you can build longer strings of more PV panels in series. This usually avoids the extra cost of a combiner box. If you have 2 strings per PV input on a PSWH inverter, it is usually sufficient to use a Y cable and you do not need a combiner box. This depends on the maximum permissible current as defined in the spec sheet of your PV panel. Prepare the positive and negative wires between the area of installation of the inverter and your PV array outside. Take into account the PV cable cross-section as required by the Any-Grid manual. PSW-B inverters will tend to require much larger PV cross-sections due to the higher currents involved and the lower voltages. Once you've determined the correct length of the PV wires from your PV array to the inverter, make sure to route them without any kinks and safely in cable channels, etc. to your inverter. Do not connect the PV wires to your array yet. First, install a breaker on the positive and negative lines of the PV array. Make sure the breaker is sized according to the Any-Grid manual and make sure that it is in the open or disconnected position. Now you can proceed by connecting the PV array to one end of the cable pair. For the inverter side, remove insulation as explained in the Any-Grid manual and insert the positive and negative wires into the corresponding PV terminals on the Any-Grid inverter. Screw the PV terminals with the appropriate torque as described in the Any-Grid manual. If instead you own one of the PSWH devices that does not have a classical screw terminal for the PV input, but instead has MC4 connectors, proceed according to the Any-Grid manual. This will require removing some insulation from the PV wires and then crimping the MC4 connectors included with the Any-Grid onto the PV wires before plugging the MC4 connectors into the appropriate and correctly polarized PV input of your Any-Grid device. In the case of the Any-Grid PSW-B, it is not possible to stack units to increase power on a synchronized AC line. For the Any-Grid PSWH, however, this is possible, typically with up to 9 units configured in single-phase parallel, split-phase, or 3-phase configuration. If your installation includes multiple Any-Grid PSWH units to be used together in a single cluster, you will require parallel communication cables and potentially also current sharing cables, both of which are included with every Any-Grid PSWH unit. Now is the time to install the necessary parallel communication cables and current sharing cables as necessary and as explained in the Any-Grid manual. Every Any-Grid PSWH in the cluster will require a parallel communication cable connection to its neighbor or neighbors. The current sharing cable is only required if you have more than 1 unit per phase, and the current sharing cable is only required between units on a single phase. It may not be used to connect units across multiple phases. Reinstall the bottom cover that you removed earlier to cover up all of the terminals and to make sure that nobody touches the terminals inadvertently. All of the wiring is now completed for your Any-Grid PSW-B or PSWH system. Double check every connection and make sure that all of the screws are torqued correctly according to the requirements of the manual. Under-torquing or over-torquing can have severe consequences as explained in the best practices wiring video linked below. To power up the Any-Grid, for using an Any-Grid PSW-B, first connect the battery. Do this by flipping on the breaker between the battery and the Any-Grid PSW-B. Now turn on the load on/off button to make sure that the AC output is activated. This should allow the Any-Grid PSW-B to power up. Then add the PV input, the AC input, and the loads in that order by flipping on the corresponding breakers. For the PSW-H, the order is a little different. First, connect the AC input, then press the on-off switch to make sure that the AC output is activated. This will power up the Any-Grid PSW-H. Then proceed by activating the PV input, then the battery, and finally connect your AC loads through their corresponding breaker. Now that your Any-Grids are up and running, take the time to program them correctly. Programming is usually only required after installation, as these are typically set and forget devices. Once the necessary values are entered, the Any-Grid will work according to these rules day by day and help you save energy or provide power where there was none before. It is particularly important to pay attention to battery settings. Some batteries are notoriously sensitive, so it is important to respect the manufacturer requirements regarding charge current, charge voltages, and minimum discharge voltages. Depending on how your system is used, it is also very important to set up the priorities. Your system may be used to act as an uninterruptible power supply, in which case the battery is essentially sitting idle for most of the time, ready in case there's a blackout. In other cases, you might be completely off-grid, or you may be voluntarily off-grid, where essentially you go into off-grid mode whenever you have sufficient energy between PV and battery. As soon as the battery is depleted, according to a voltage you define, the system will automatically go back to the AC source, such as the grid, for example. This allows you to save on your power bills by minimizing the use of energy from the grid and maximizing the use of renewable energy coming from solar. Finally, if you have any more accessories, such as the Any-Bridge AB PLC monitoring and control gateway, you can connect these now to monitor your power system. Rules and regulation vary throughout the world with regards to electrical systems. Please observe the rules in your location of installation. Phocos cannot be held responsible for any deviations from these. We wish to thank you for watching this video and hope that you will find other content on our channel. Please don't forget to subscribe to our channel so you can always get the newest content from Phocos.
For more videos and information, go to www.phocos.com. Phocos, making reliable energy access possible. Anywhere, anytime, any grid.